Good morning, everyone. Let me just get this started. All right. Hi. So I think so far we've had a really great conference, and we've had so many great workshops and talks about how to use R better, how to make better data science, how to learn different methodologies, and so on. But what happens when you work in an organization, maybe not in academia, maybe also in academia, I don't have that much experience, where not everybody knows and gets what it is we do. And then they don't always know data science is still a new function, and they don't really always know when to involve data scientists or analytics teams. So, and yet, all of these organizations would say, oh yeah, we really want to be data-driven. We really want to make the best use of the data we have. But we're not going to train everybody in analytics and algorithms. And just as much as we don't train everybody in general programming or design, or not everybody knows how to write a contract, even though all of those functions exist in the organization some of us work in. So how do we get to a point without teaching everybody all of these skills that we have, that we still have people know when to seek out our advice or when to involve us in their processes as they work? That's what I would like to talk to you about today. So what is the role of a data culture in the organization? So, and why do we need it? So I tried to neatly put this into three points. So I think partly it's about trust. We need to build trust. We're still a new function in these organizations, and we need to build positive communication, not just frustration that we weren't involved in the right time. And we want to also share a passion that we care about what we do and we care about making an impact. I think it's also about access. From the beginning, making data accessible, having other people have access to it, see it. It's not just something that you do on your laptop and then tell them what you found, but making sure people can see it and touch it themselves. And then making knowledge accessible, making sure that people understand what it is you're doing, and how to best utilize the value that we create. And last but not least, knowledge. I think it's really important that people understand the data science function in the organization, and again, when to involve data scientists in projects, from marketing, product, and other functions. So I think that sounds like a good, positive way. If we have this set up, this data culture set up in an organization, then we're good to go. I think we should be data-driven. So I would like to give you a few examples today about not just why we should do this, but how do you get an organization to have this data culture. And I do all sorts of various trainings, workshops, and talks within the organizations I work with, together with a lot of wonderful colleagues. And we try to talk about all sorts of different topics in data science. And I wanted to give you a few examples of how and what we do in order to establish a data culture. And before we begin, everybody knows this quote? Anyone can remember who said it? Yeah, Newton, very true. And you might know it from the Google Scholar, where it's often when it's on the top page. And I think like many other things in science, we are very lucky. We don't need to invent the wheel. While data science is really new on the field and there's the organization, the history of science and exploration is what we can use in order to build this culture. It's something that's immediately accessible to everybody, very much is in line with what we do. And we can draw on that existing culture of science and exploration in order to create a data culture and a data-driven business. So how do we do this? I'm going to do that the same way, exactly. I lifted examples from all these things that I already have done. I'm going to use no equations. This should be accessible and easy to get. And I'm going to use no code. And I'm still going to try to get you excited about shaping the data culture around you, instead of using math and statistics. And I will try to use stories and kind of like all sorts of examples that have like memorable moments to them. Things that you would take home and say, I don't remember what the equation was like or something like that, but I do remember that it was referring to that funny bit or to that interesting point. And that's how I try to do that. So what stories or examples are we going to look at? I'm going to talk to you about climate change, about parole decisions, about dinosaurs, and I'm also going to talk about mozzarella cheese, and one of my heroes, James Lind, and hopefully by the end of today, one of your heroes as well, if you haven't heard of him yet. So I hope I got you at least a little bit intrigued, and maybe we could get started with our first bit, climate change. So this is Douglas Mawson. He led an expedition to Antarctica aboard the Discovery in 1929 to 1931. And they made really so many significant findings and explored Antarctica when we knew very little about it. But on top of the science they did about Antarctica, they also kept meticulous records of weather conditions. This is not something they were studying. It's something you do when you're on a ship. It's just a regular thing to keep measurements, to track what you're doing and what's happening. And today, all of these records are being digitized and are helping us study climate change so that we know what temperatures and sea levels was like in those days, since people weren't tracking them and studying weather in Antarctica actively back then. So I think what the point of the story and what I use it to illustrate is that we don't always know why we need to gather specific sets of data. We don't always know what we would use it for in the future. And we should always care about data quality and how we maintain our records so that we could model and implement our tracking with the long-term consequences in mind, with the questions we don't know yet that we're going to be asking. Not just maybe the next feature release, but what might this be valuable to our business in a year or two? And often at work, we work at a very fast pace, one feature to another, one campaign to another, and not necessarily thinking about the long-term horizon of the data we need. So this is actually part of a workshop that I do about tracking, design, and testing, where we're bringing all the stakeholders, developers, quality assurance engineers, product managers, and data analysts, to discuss all the different needs and use cases in order to align our processes and how we get things in order. And people remember that, wait, we need to do this because climate change. So it is kind of something that you hear people talk about later on when they need to remember to ask someone about adding a tracking or making sure that it's useful. Next, parole decisions. So if you're interested in product analytics, which I find fascinating, you might also find behavioral science very interesting. And I wanted to show you one of my favorite examples of behavioral research. It's from a paper that's called, it's a very catchy name, no one forgets this. And it's actually about parole hearings. And it has fascinating insights. As you can see, they're illustrated by their main finding right there. I think it's obvious, right? There's like a paragraph or two of text under this plot that explains it. And I really think that we could make this slightly more obvious. Does anyone want to guess what the circles are? No? So does this help? So it's really one small change, and then you don't need a paragraph of text after the plot, right? And then you already have a easy, accessible, again, understanding of the key finding, and you can always make sure and encourage people to make sure that their graphs and plots communicate their findings easily, that you don't need to also read, that you don't need to get things that you could communicate much simpler. So this parole decision topic is actually from a training about data visualization. We discuss the fundamental of visual communications and applications to data visualization, and we learn how to improve our reports. We take things we already did and recreate them using visual communication methodology. So I think it's as important as presentation training, but I might be slightly biased since I run this trainings myself. third, dinosaurs, and this might be something that quite a few of you know. It is the most mathy and complicated example I have, so it shows you maybe the range of what we do. These are random numbers, and here is a summary statistics. There's a long list. There's a lot more. When I present this, I always explain what means, what standard deviation and what correlation is in simple English. There's simple English Wikipedia. It's very accessible, and you can always make sure that people are with you. But I assume in this crowd, I don't need to explain the standard deviation. So if I plot all of these numbers, and if you know the answer for sure, then please don't say it. What do you think they look like? And I already gave a big hint in the beginning. Yeah. So this is what it looks like. So that's easy. Now I can explain to my stakeholders, whenever you see these numbers, you know that you're looking at a dinosaur. That's very easy. But of course, this is not what it looks like. All of these plots have the same summary statistics. And that's something that is often not as tangible or accessible to people who don't touch data and do statistics all the time. And this illustration, which I really like and recommend, is called the Dinosaurs dozen. It was created by Alberto Caro and kind of based on even older example from 1973, which had 4 plots, which called the Anscombe's Quartet. I don't know if I'm pronouncing that right. So my takeaway for people who participate in this is, if you don't look at your data, the dinosaurs will eat you. And you should remember to always look at your data and don't just take a mean. And we talk about different types of distributions and how the fact that skewness and long tails can make you not want to use an average. And then, of course, there's also this, which helps make it also memorable, so people tend to remember that one. I prefer the Dinosaurs, but not everybody remembers a dinosaur made out of dots. So this illustration is actually taken from a talk that I do about how to use numbers in decision making. We simplify our approach to numbers. We say when you meet a number, you should ask yourself 3 simple questions before you use it for decision making. And one of them, of course, is to always look at the data. That's the most complicated one. And again, if you're not sure, if it's not normally distributed, then have a chat with a data scientist or an analyst in the company and make sure that you're using the data correctly. All right. Next, we have mozzarella cheese. So I'm sorry if anybody didn't have breakfast. Since 2000, every year, Americans have been increasingly consuming more and more mozzarella cheese. In the beginning, it was about 4.3 kilo per person. Now it's already over 5. And at the same time, over the same period, this is the MIT campus, one of the top schools for civil engineering. And every year, more and more civil engineers are getting doctorate degree thanks to the work down here. I'm sure you can tell what's the connection to mozzarella cheese, right? So this is actually about spurious correlations, which, again, might be very obvious and relevant to anyone who studied some statistics, but really hard to remember, recall, reuse when correlations are so tempting to just like, look, they really go together. It does mean something. So I don't think we should use one to predict the other, and that's very easy for people to understand when you show them very clear examples of why correlations are not necessarily meaningful. But they could be really great resources for jokes. And just to illustrate the point, there's Google correlation tool, and I always try to add an example that is relevant to what people do. So for today, in case you are organizing meetups for our user groups or our ladies, I wanted to help you all out. I think when you plan your meetup and how to reach more people in the US, you should definitely think about people who are using the search term how to make a baby, because those two are really moving very much together. It's R0.98, so that's quite impressive. So yeah, and not least, there's an XKCD about it, and people love XKCD, so you should use it. And this more tasty example is actually for a talk that I talk about common pitfalls in applied analytics, or why it's never a bad idea to check with a data scientist about how you interpret your numbers. So again, it's just empowering people to understand maybe concepts that they haven't met mathematically. And then we're going to move on to my hero as promised, and possibly, spoiler alert, the answer to spurious correlations, or what you should be doing instead of looking at correlations. So this is James Lind, and in 1747, he was a young Scottish naval surgeon, and he boards the HMS Salisbury, and about to join history. So I don't know if all of you know about scurvy, but it is a vitamin deficiency that was very common in sailors at the time. They would have rotten gums and general decay of skin, bone, teeth, basically anything that requires collagen. And we all know that vitamins are organic neutral, that they're vital, that we need them, and that our body cannot produce them. But vitamins weren't discovered yet in 1747. So unfortunately, James Lind couldn't have known that. And the disease killed about 2 million sailors, and taking the population at the time, that was quite a substantial disease. So James Lind decides to do something that was unheard of. He decides to do an experiment, something that hasn't been done yet. He takes 12 patients and he splits them up and gives them the best medicine of the time to scurvy. And that actually was salt water, vinegar. There was also the option of burying someone in the sand up to their neck, and hard labor, because often cause and effect were confused. So it was associated with lazy sailors. Scurvy was associated with being lazy. And actually, oranges and lemons were shot in the dark. They were just like something he had around. He was like, let's put in something that doesn't do anything and see what happens. Of course, what actually ends up having is that the 2 sailors who get oranges and lemon have remarkable fast recoveries. Actually, in 5 days, they ran out of fruit, but they were already mostly better. So the 2 sailors that got cider had mild improvement because there's still some fruit ingredients in cider, and everybody else just got worse. It was quite important to mention that they all received the same food, they were all housed in the same portion of the ship, and they all received the same care, which is, again, kind of an innovative approach to checking and comparing different methods in medicine. And just right there, James Lind did the first controlled clinical trial. It was a very small test, but it had really remarkable results that they could make a finding right away. They had no understanding of the cause, but that's not the number one criteria in medicine. They first cure the person, then figure out what was ailing them. Of course, if he was researching these days, we would have all known about him. He would have appeared at major conferences and made major papers. But back then, it took him 6 years to write a long book about it, and therefore his work was completely lost. It was reinvented later on by someone else, and only when we discovered his papers in Scotland did we realize that he actually invented and ran the first controlled clinical trial. So this story about James Lind and the cure for scurvy is actually from a talk about A/B testing, and where I kind of go through the history of the scientific method and illustrate important concepts in A/B tests. So this is very much my last slide. So I just wanted to mention that data science doesn't have to be exclusive or complex, and that you should seek out stories and tell stories in your team and to other people around you in order to make sure that it spreads out and is memorable and is accessible to everybody around you. So that's it. Thank you.
Thank you, Noah. Are there any questions?
You said in your dinosaur eating example that you said that there were 3
Right.
bits, but that you didn't mention them.
Right. I think it was how big is it? How is it measured? How big is it? And what does the data look like? How is it distributed?
Any other questions?
Yeah.
Maybe you have perhaps a story for managing expectations, because sometimes people see that there's value on the data, but they expect, you have a silver bullet as a data scientist.
Right. What I usually do, I kind of skip that slide to condense it a bit, but I remind always people that what we do is data science, that often data science is a social science, and even when it's not, it's still a science in progress, that we are discovering and re-understanding things that we did before and things that we're going to do ahead, and that it's going to move, and we might actually come back to you after a while and say, okay, we know better now, or we know different, or we have doubts. So I try to make sure that people understand that what we do isn't, and even again in the history of science, if you go again from Newton through all the understanding that we're not in the center of the universe and so on, those are things that you can tell with scientific examples. Yeah.
One quick question.
They are talks. Can we find them anywhere?
Actually, they're not published. I usually do them in the organization I work with, but I could probably, if you're interested, kind of put some stuff online. Yeah.
Great. Let's thank her again.
Thank you.
Okay, the next speaker.